All right, so your notes today should reflect that we're looking at the last section in this chapter. We're graphing. We've been graphing this entire time. However, this is the first time that we're talking about graphing in two variables. Everything to this point has been one variable. Doesn't matter what that variable was, but one variable gets graphed on a number line. Two variables have to get graphed on two number lines, and two number lines together is a XY axis, okay, is a coordinate plane. So that's why you have a paper in front of you with that information. There are two word problems on the one side. We may or may not get to both of them. We'll do one for sure. We're going to use, however, the other three graphs on the other side to kind of illustrate this idea of what this looks like. Okay. So as you kind of think about what this is going to look like, think how we graphed on one number line. We used an open circle or a closed circle. We pointed to the right, we pointed to the left. When you graph on two number lines on a coordinate plane, it's got to look a little bit different. There's no such thing as pointing to the right or to the left of a line that you draw. That's not going to make sense. Okay. There's not going to be the use of an open circle or a closed circle on a graph. You're not going to be able to see the difference between those. So we have to make a couple of adjustments. Any idea what those might look like? Anybody played with this idea on Desmos? No? Okay. Ouch. All right. I I got you. I got you. All right. So that's what we're going to look at today. How do those graphs look? Okay. It's not going to take long for you to kind of get into this routine. It's not going to be. I don't think it's going to be that big of a deal. So can we graph on a coordinate plane? Number one. Then can we solve them? To solve them, that means we need solutions. So we'll talk about where do we find solutions. If you have anything other than a pencil with you today, might not be a bad idea. You can shade with a pencil. It's not a problem. But if you got a highlighter, crayon, marker, pen, something that shows another color, that might be helpful. That might be useful. If not, no big deal. Like not the end of the world. Okay. All right. So, all right, we're just getting a highlighter. Like I don't know, it's that big of a deal. I mean, for some of us, it is a big deal. Okay. So vocab that we may run across today. The boundary just simply means the line between what's good and what's not. All right. The half plane is what we're going to try to identify. Then we'll talk about whether that half plane is open or closed. So instead of the circles being open or filled in, how does that look on a coordinate plane? So yeah, this idea of open versus closed is the same as it is when you're talking about open circles versus closed circles, like whether you're allowed to be that answer or not allowed to be that answer. But on a coordinate plane, it looks a little bit different. Now, this definition here of a half plane, it's kind of misleading. All right, so a linear inequality describes a region of the coordinate plane called a half plane. Here's what we're trying to say. Here in a moment, we're about to do something that looks like this. We're going to have a graph. We're going to draw some line across that graph, and we're about to have to make a decision about which side of that line are the solutions on. Okay? On a number line, we pointed one direction or the other. Here, we're going to have to identify, is it this area at the top or is it this area at the bottom? Okay? We call this the half plane because really this coordinate plane extends on forever. Okay, there is no end there. And because there's no end, there's no middle either, as vague as that sounds. So this line, this blue line right here, cuts this graph in half because it goes on forever. What's half of forever? It's wherever the heck you want it to be because it's infinitely the same on both sides. Okay. So just because right now the bottom looks bigger than the top does not mean that this is not cut in half. It doesn't even matter if all you had was this tiny little spot right there. That's still half. Is that are you following that idea? It just it as much as you see below is as much as you see above because neither one of them stop. So don't feel like half has to do something like that. That is not true. Okay, half is wherever the heck that line is at. All right. Now when I'm doing this, here's kind of my rules for how to make this happen. The first one's kind of an obvious one. You can't graph if you don't know the slope and the y-intercept, right? Okay, so you got to know those two things. Here's where it gets a little bit different. If we're supposed to have an equal to, on a number line we filled in the circle, but on a coordinate plane we draw a solid line. So basically we connect all those dots with a solid line. That's essentially saying the same thing as filling in the circle on a number line. If we're not allowed to do that, if it's just a less than or a greater than, then instead of using an open circle, we use a dash or dotted line. Okay? Nothing crazy. And then the last part, we shade. If it's greater than, we shade above. If it's less than, we shade below. On a just one number line, we pointed to the right for things that were bigger, to the left for things that were smaller. Okay, so it may look like something like this. Now that's two of them at the same time. Okay, but it could be a solid line with shading above it. By the way, that would be greater than or equal to, because the line is solid and it's shaded above. What's up? Then the line goes downhill. Well, so if you thought about having some like XY axis there and you had a line that was going downhill, where is the above side now? Is it to the right or to the left? To the right. So this would be the above or greater than side, and down here on the bottom, that would be the less than side. So, you know, that's a good question. I mean, and here's the other option then. So that's dotted, which means it does not have an equal to, and it's shaded below, so that would be a less than.
So the dotted line is like just the regular less than.
Yes. Yes. Yep. It's the same as basically saying an open circle. And then the solid line is like having the filled in circle. We just can't do open and closed circles because you're about to draw a line through those. Now we're going to try to get into whether or not your circle was open or closed. Like it just doesn't, you know what I mean? It just doesn't make sense. So we use the line to do that for us. All right. So we're going to look at a couple. First one's going to be relatively easy because it's already kind of ready to go. All right. So on your graph paper, yeah, like on the side over there, if you haven't, I would really ask that you write that inequality first before you go trying to graph it. Now looking at that though, you should be starting with what? Start with your y-intercept. So a value of -3. And now you have a slope of 2, so go up 2 and over to the right 1, right? Slope of 2 over 1. So up 2 and to the right 1, 2 and to the right 1, and just, whatever, a couple along that path. Now here's the only part that may look a little bit different. We have to make a choice and decide whether that line should be solid or dotted. In this particular case, it's going to be solid for what reason? Because it's got an equal to. So go ahead to the best of your ability and make a straight line. And the last decision that I have to make here, typically because this says less than, I would be pointing to the left if I was on a number line. Here, I have to decide which side of this line is, quote, the less than side of the line. Do not ever make it under the assumption that one is bigger than the other, and therefore the bigger side is the greater than side, and the smaller side is the less than side, because it has nothing to do with that, okay? As you look at that line right now, let's just call this side over here side 1 and this side side 2. Which side do you believe is the, quote, less than side? Quinn, what do you think? Side 1? Okay. You agree or disagree? You agree? Okay. You disagree? Good, those are our choices, right? It's one or the other. You disagree as well? Okay. Let me give you this to help. If you were on that line right now, if I drew you on that line, what side of it would you be standing on? On side 1 or side 2? On side 1. If this line from left to right is going uphill, right? So if you were a little person, as bad as that looks, you would be on that side of the line. Correct? Okay. You will always be on the greater than side. Because if you were on the other side, you'd be like hanging upside down like a bat. Do you? No,
you weren't. It's the other side.
No. Because you will, right, but look at the sign. We want the less than side. It's okay. All right. So in this situation, we do actually want the less than side, which would be like the ground, so to speak, and it would be this side over here. That's okay. I'll show you another method here in a minute to help you figure that out. Okay. So we would be shading the bottom of that line.
Whatever side you be standing on, so who's going to be spreading
Okay. So just for a second, stop. If you had a line going this way, going downhill, where would you be standing? You'd be standing over here, right? You would be on that side of the line, which means that side of the line is what? That's the greater than side. If you were over here, think about it. If this was you, and you were over, you'd be hanging upside down. Okay, so if you're not able to stand there, then you're not on the greater than side. So that'll at least tell you what side's greater and what side's less. Okay, now what's the point of shading that? Is what we're doing here is we're identifying things that are solutions. Meaning, if you give me any ordered pair over here that's in the yellow, that is a solution to this inequality over here. Okay, so how many solutions are there? There's an infinite number over there, right? I mean, as long as you pick something along the x-axis that gets you into the yellow, and then on the y-axis that keeps you in the yellow, you are a solution to this problem. Are you allowed to pick something that's directly on the line? Because it's closed. Okay, because of the equal to, it's closed, so therefore, yes, you can pick something that's on the line. So part of your homework tonight, there's going to be a picture, and it's going to say, here are 6 choices. How many of those choices are solutions? Are you going to pick more than one? Probably, right? You're going to have to look at them and determine, do they fit in that area or not? Okay? All right. If that didn't help, I got one more strategy for you. We'll use it on the next one. All right? So if I want to graph this one, can I graph it the way it currently looks? Yeah, not really. I mean, maybe. That's in standard form, but I think it's probably easier if we solve it for y. So if I solve that for y, what do you got to do first? Aiden, what do you got to do? Okay, so minus the 5x to the other side. You get 2y's greater than what? Ben, which of those two numbers am I writing first? Think y equals mx plus b. So the negative 5x or the negative 8? The negative 5x. So you should write negative 5x minus 8. I'm about to divide. Am I going to flip my sign? Why not?
because it's positive.
So I'm not dividing by a negative. So in this end result, this is going to be left with y is greater than something. What's up? Oh, so go ahead and graph. You already graphed it? You got to do a little erasing there on your line. Not the whole line.
Oh,
It's dotted. Yeah. Now, what's up? Okay. So your slope, you tried to slope it. Just open it up a unit. Your slope's right there. All right. I'll be honest with you. You grab a calculator right here, you're going to make me nervous. Because if you take negative 5 and 2 and you divide it, what are you about to get? You're going to get a decimal or maybe a mixed number. Either way, not things that are nice if I'm about to graph. Look at those numbers. Leave it. Negative 5 over 2 times x. That's great to work with. Oh, I'm about to do that right now. Right, I just did this one. That's that response. Now I have to do the 2 and the negative 8, and that gives me an answer of negative 4. So my goal at this point is to graph this. I'm sorry? Negative 8 divided by 2. That gave me that one. So we're starting with what? Starting with a -4. Then we're going to that slope. And then we're going to try to figure out what it means to be greater than. It's okay. Yeah. So your graphs only go down 8. So you don't have enough to go down 5, right? So we're going to go up. We're going to go up in which way? To the left. Good. So we're going to go up 5. 1, 2, 3, 4, 5, and to the left 2. Okay. Yeah, we're going to try to make our best straight line. Except this time, though, we need to make sure that our line is what? Dotted. Okay. Why is this line dotted? There's no equal to in this problem. So can you what? Well, yeah, you got to make that boundary. So whatever that would be. Now, if you made a solid line in the first place, then just flip your pencil over and erase just little bits of it out of there. You know what I mean? Just erase little bits. Okay. All right. So right now, I'm trying to identify the greater than side of this line. Okay. If you're not certain of what the greater than side is, here's all you have to do. Pick a point that is not on this line, and we're going to use it to test to see if it's right or not. Okay? Now, we're going to pick any point we want as long as it's not on the line. So let's pick the easiest possible point we could pick. That's not a point. 0. No. 0. Yeah. If 0, 0 is not on your graph, and in this particular case, the ordered pair 0, 0 is not a part of my line, I'm going to use it to test. Okay, so here's what that's going to look like. I'm putting a 0 in for y. I'm putting a 0 in for x. And I'm going to solve this. So it's going to say 0 is greater than -5/2 times 0 minus 4. One. Well, hold on. What happens when you do -5/2 times 0? So that goes away. So you're left with 0 is greater than -4. Is that true or false? That's true. Okay, good. Which means that everything over here, where the point was that we chose, since this point was true, everything over here is true. Which means I want to shade this side. That's fine. What side would he stand on? He'd stand on the greater than side. And I wanted greater than, so I'd shade where he would be. No, he wouldn't. If you drew the guy, he would be standing over here. And he's always on the greater than side. You want to know what I really did? This is sad. Check this out. I have the I shouldn't even look. Where is he at? This is my guy. I drew him and saved him. I thought he always going to slide on the greater than side. Right? He's a snowboarder. He's got his backwards hat on. Right? No, that's just how I think about it. That's just I don't know.
On the last one, the guy was on the non-highlight.
Okay. No, he wasn't. Stop. He is always on the greater than side. That doesn't mean that's the side I shade. Okay. In this problem, there he is on the greater than side. But look at the symbol. What's this symbol? Okay. So here, this just simply meant if he's on that side, this is the greater than side, and that's the less than side. The question said we wanted the less than side. So that's why I'm shading that side over there. Here, same thing. If he's over there, that's the greater than, this is the less than, but the problem says I want the greater than side. So in that particular case, I'm shading towards him over there. That's all it means. Yes. Yep. Yeah. You just got to figure out what's the greater than and what's the less than side. And you can do that by using the little dude. You can do that by picking a point. You can do that by just recognizing what's the quote high side and what's the low side. It really doesn't matter. All right. Now you have 3 graphs. So here's the third one. Did he give you the test? He has it in his room. Sorry. Thanks. Now remember, you just want to get y by itself. So before you go getting all crazy moving stuff around, stop for a second and think, what's the easiest way to get that y by itself?
I did that.
Yes, that's exactly what I did. Okay. Now, if you're going to move it, though, you got to move it to the other side of the inequality. It's got to go over by the 0. All right. Uh-huh.
Would I just sign change it?
If you wanted to, you could flip the whole thing around so you saw the y first.
Okay, I'll do it.
But if you do that, remember, you got to flip everything. So go ahead and graph that. What do you got? Well, you also have to move the 2. And you don't probably need the 0 anymore now that you have something over there on that side. So how are you going to move the 2? Okay, so minus the 2. Yeah, why don't you just take that whole thing and flip it? Like put the y here, put the 4x plus 2 over there. But then the sign. Yes, it is. Very good. Yeah, that's what I did.
Wrong.
Yeah.
That means I messed up the whole thing.
Well, you messed up that part.
That was right.
Well, you lost your x.
Yeah.
Well, yeah, I mean, look, there should be an x over here. And there'd be an x there. Now that 2 still got to go over there too.
So it'd go.
You'd have to minus it to the other side as well. Okay, now you got to get rid of that negative in front of that y.
No.
Divide it off.
Positive side.
Uh-huh. And that's what you want. You want greater than. Okay. Uh-huh. So go. What are you going to do with it? Greater than.
Okay, so I thought I was trying to find it.
Yeah. All right. So as you're kind of working your way through this, please understand that for a moment, what you're trying to identify is how do I get y by itself? A lot of you guys moved the 4x, then moved the 2. Gracie, will you answer that? Well, so you divide off a -1. It's going to switch your signs. When you do that, then your inequality is going to turn. Okay? All right. Now, I think the easier move here would have been for you to just move the y to the other side. You would have had y by itself and already positive by just moving y to the other side. Stop with the pens. Okay? Now, that leaves you with 4x plus 2 is less than or equal to y. Right? That might be a little bit difficult because y is not written first. So if you just flip-flop it, so switch the y and the 4x plus 2, your symbol then turns into a greater than or equal to. That maybe is a little bit easier than all those other things. You colored the wrong side of the line. Correct. So take the face back. All right. What? We haven't even done it yet. I try to. Now, there's your plus 2. Your slope is 4 over 1. It's steep. 1, 2, 3, 4, and 1. Or down 1, 2, 3, 4, and to the left 1. Is the line solid or dotted? Solid. So, solid line. And the last thing now is I want the greater than side. So in this particular situation, the guy always stands on the greater than side. I want that side. So is it to the left or is it to the right? It's to the left. It is this side over here. That is that is where your solutions will be found. So before you go trying to color, I think you need to identify where's the greater than side, where's the less than side. And if that's not holding for you, then I'm telling you, pick a point. Pick some point that is not on this graph. Okay? So, or excuse me, not on the line. I shouldn't say not on the graph. So I would take that point right there. 0, 0 is not on that line. If you put zeros in for these two values, if I put a 0 right there and I put a 0 right there, I would be left with 0 is greater than or equal to 2. That's false. So because that's false, that means this side over here is false, which then means this side over here is good. That's what I'm after. So you can do this in a handful of different ways. Some of you guys are just going to naturally pick up the idea of what's the greater or less than side quicker than others. That's life. That's how everything works, okay? Some people just see things differently than. So I'm trying to give you multiple options so you can find one that you say, yes, I can do that. All right? Obviously, picking an ordered pair is probably the slowest method, but it will work for you every time as long as your math is correct. All right? What's that? Yep. As long as you don't hang him upside down and then try to call that the greater than side. Don't hang. He's not a bat. Don't hang him upside down. All right. What if, let's take this away. What if we flip it around? I'm going to give you the picture. I'm going to ask you for the inequality. How many things are necessary for you to tell me the inequality? Tell me something that's necessary. So what are you talking about there? Yeah, what are you talking? What's that called? Your good. You got to know your inequality. Tell me something else you got to know. Got to know your y-intercept. That's 2 things. There's one more thing you got to know. Got to know your slope. Okay? So, in the statement, y equals mx plus b, I have to be able to change the sign, the slope, and the y-intercept. Those 3 things I have to know. Now, depending on where you're sitting in the room, it may be hard for you to find ordered pairs. That is a definite cross of an ordered pair, and so is that. So that might make it easier for you to find the slope from where you're sitting. Okay? So right now, tell me one of them. Like, give me something. Either what's the inequality sign, what's the slope, or what's the y-intercept. Give me one of them. The slope is 3 over 4. If I counted up 3 and to the right 4, I would have a slope of 3 over 4. Okay, that's one thing. Aiden, give me something else. Or are you just stretching? Okay, so your y-intercept is a positive 1, right? Get that from this point right here, so plus 1. The only thing I don't have is what's the inequality that goes in there? Jack? Greater than. So your line is dotted, which means you only have 2 choices. Since your line's dotted, it's either greater than or less than. It's not necessarily which way it's going. That's going to tell you your slope. Okay, if you thought about if I brought him out, what side of the line would he be on? Would he be on this side? Then that means he's on what side of the line? The greater than side. So your symbol would have to match that. Okay. What's up? That's all right. What's up?
How did you?
Yeah. So
How did you know your y?
Well, because that's where it crossed the y-axis. So that value right there was 1. Because think in reverse. If I Oh, okay. Yeah, I mean, if I gave you this inequality here, y is greater than 3/4 x plus 1, and I said graph it, the first thing you would do is start at that plus 1. So you'd put a dot on 1, right? All right. So let's try it one more time. Same thing. Here are values that are crossing. So if you can't see that from your seat, those are definite ordered pairs. So we need 3 things. Well, before you want to raise your hand and tell me one of them, like give it a shot from beginning to end. What do you think it looks like? Like what is the whole inequality going to read? What's your question?
Like the last one we did,
Uh-huh.
there's like those dots. On this one, there's not.
Correct. So that tells you there's.
No, it actually tells you. I think I got it.
You all right? Okay.
Oh, do you want me to write it down?
Well, that would be the goal, yeah. The only thing you need to fix is your sign. Don't erase. Your line is solid, which means, yes, it would have that in it. That's the greater than sign. Where you at? So you're where does that cross the y-axis?
That's the thing.
A negative what?
Uh,
Count down.
Oh, I was looking at the wrong spot.
Okay, so that's your y-intercept. Yeah. Yeah.
So how do you find your y-intercept?
Where does it cross the y-axis?
4, 3, I don't know.
Look at that vertical line, the y-axis, and look where that red line hits it.
Oh, okay. So it's 4, negative 4. 3? No.
It is not counting by twos.
Because there's a line.
Oh, okay. So negative 3.
Yes, negative 3. All right, so if I take the original y equals mx plus b, I've got to find 1, 2, 3 things. I think we've established at this point the y-intercept is what? Negative 3. All right. So we're putting a minus 3 on the bottom there. Logan, give me what are you going to give me? Okay, good. So the line is solid, which guarantees that there's an equal to in there, and we are on the greater than side of that line. So we're looking at y is greater than or equal to. Aiden? And your slope is down 2 and over to the right 1, so that is a negative 2x. Okay. All right. On the other side of the paper I gave you, there's 2 problems. We're not going to be able to do both. I'm sure you're really dying over that. So we're just going to look at one of them. We're going to look at this one here. Okay, because really this is what you should be able to do with a 2 variable inequality. We should be able to come up with a picture and then use that picture to produce results in relation to a problem. And so here's our question. Write and graph an inequality to represent the situation about this. I'm guessing it's a Boy Scout troop or a Girl Scout troop, I guess. They're selling cider and donuts. Boxes of donuts are $1.25 a piece. That's super cheap. Better get some of those. Cider's $2.50 a gallon. That's cheap. They're not making good money here. They could be charging way more. Okay. In order to cover their expenses, they will need to make at least $100. So that's what they got in supplies. Okay. Write and graph an inequality. Good. That's a great start. You all should be able to grab an inequality sign right now. There's 2 words in there that would tell you the inequality sign. What are the 2 words? At least, which should tell you it is beautiful. So we all should have that. Greater than or equal to what? 100. There's no reason we can't have that on our paper. Now, on the other side is where we're going to have to use some of this information right here. Donut holes, $1.25, cider, $2.50 a gallon. By looking at my graph, I should know which one is my X variable and which one is my Y variable. It's already told to me. What you got?
So the X is the donuts,
X is your donut holes.
and then
Yeah.
Y
Is your cider. Good. So tell me what I need to write on the left-hand side that needs to be greater than or equal to 100. What do you think? Okay. Now, I'm going to switch out the C and the D for an X and a Y so that we know where we're about to graph these. Are you okay with that? Okay. So could I say 125X plus 250Y? Does that work? Okay. Now, that's in standard form. AX, BY equals C. Okay, so we got two choices. We could solve this for Y, or if we could come up with two ordered pairs, we could plot those ordered pairs and draw the line. What do you think is going to be easier in this situation? What do you think, Logan? What's that? Solve it for Y? Okay. Can I disagree with you? Here's the only reason I say that. In my mind, when I think about standard form, here's the first thing for me that comes to mind. Do you know what I'm indicating with those two ordered pairs? Aiden? But what if one of those is a 0? Do you know what I'm finding? The X and Y intercepts. Like if you put a 0 right in here for X and made it go away, you're basically saying sell no donut holes, just cider. Like, can you give me an answer to that? Like with a calculator, it should take you like less than 10 seconds to tell me. I don't think so. You multiplied by 100. You didn't divide by 100.
Yeah, that's probably
40. Which means you could make your $100 by just simply selling 40 gallons of the cider and being done. Boom. There's an order pair right there. And if you did the exact same thing with donut holes instead of cider, essentially you're making the 250Y go away. How many boxes of donut holes would you have to sell to get your $100? 80. So here, I'd have a value out there at 80. Now, could we have solved this for Y? Absolutely. But was that quicker? I think just like in the last problem that we graphed, you could move the 4x and move the 2 and switch the sign, or you could have just moved y to the other side. We get the same thing. Maybe one's a little quicker than the other. All right. Now, should this line be solid or dotted? Solid? Because, good. Well, it's got an equal to in it. So if I draw the line between the two, the only decision I have to make now is which side do you shade? Okay, that's what I want. So what side's the greater than side? Good. In this particular case, it's this side out here, the side that's bigger. Okay. The less than side would be the little triangle underneath it. All right. So what does this represent? This here represents all of the possible solutions that could make this happen. Now, please understand that graph goes on forever. So realistic solutions end at a certain point. You're not selling 5 million gallons of cider and 3 million boxes of donut holes or whatever combination. Like, yeah, great, it works out to be greater than 100, but pallet ain't happening. Okay, so you got to understand that at some point it loses its reliability. Okay, now tonight, tomorrow, whenever you're going to do this, your homework is a form that basically covers these ideas. Okay. I'll give you a picture and ask you which one of these matches it. You got to identify its slope, y-intercept, and sign. Or I'm going to ask you what are solutions, meaning how many of these solutions satisfy the given problem. Okay? If you have any questions, you let me know.